treatment to treat a TB patient. So these are things that we are trying to look at, but not in this particular setting. Yeah, so yeah.
The last question.
Can I make a comment? Yeah, it doesn't work very well. Comment. John Michael and I, 6 years ago, were in Santa Fe at a WHO-sponsored TB meeting, right?
Yeah.
And I think this is particularly relevant for what you're doing. So this young guy that was the head of the TB program at WHO was presenting some numbers. And so my question was, I said, hey, what is the landscape of TB in pediatrics? And he kind of punted and said, that's a great question. And I said, thank you. Would you please answer it? And the reason I asked him that question is because the numbers are largely unknown. It was actually a workshop on XDR in India, okay? And the point that I'm making is, if you think about it, and John Michael and I have experienced this, there's a lot of TB in Kenya in pediatrics, but there are not good tests. Because in order to get a sputum sample, you have to make the child cough. And the little guys and gals don't know what cough means, and they can't produce a good sputum sample. So one thing I would encourage you to do is, in the assays that you're looking at, also include some pediatric populations in there. And then related to that 6-year-ago comment that I made, we've been working with the national lab at Los Alamos, and we've been developing blood and urine tests for TB. And so one of the problems that we run into a lot is, what is the gold standard? When we're talking to funding agencies, trying to publish this, etc. So what I would encourage you to do is, in your assays, include some things that are what are considered gold standards. And it's a circular argument, because particularly in pediatrics, there are not good gold standards. But you want to line yourself up with maybe some eGRIS, not in everyone, but to do that, gene expert, and then cross-validate. Because when you send that out for a publication and you want broad-based usage, people are going to not believe the results, unfortunately. And it's a majorly important area. And so in order to launch this programmatically, it's very important to put some gold standards in.
Thank you very much.
Thank you very much. We will press on after this little mini lecture here. As we heard in the beginning, of course the overriding theme here is capacity building. And I'm therefore glad that Gordon chose me to chair this session on topics I know nothing about. Probably in the hope of improving my capacity to chair a session. So I don't know anything about. So thank you very much. So with this short introduction of myself, I'm Lars Witt from Copenhagen. I will give the word to Joshua Kulape, who will tell us about glutathione S-transferase gene polymorphism and antioxidant enzyme activities in Ghanaian HIV and AIDS patients. So, Joshua, whenever you're ready, then take it away. Thank you.
Good afternoon. I'm Joshua, and I work on glutathione S-transferase gene polymorphism and antioxidant enzyme activities in Ghanaian HIV/AIDS patients. AIDS is caused by HIV, and globally, sub-Saharan Africa has been shown to bear the greatest brunt of this disease, with nearly 1 in every 20 adults being infected or living with the virus. And in Ghana, in the year 2014, about almost 1.5% of adults were actually living with this virus. Reactive oxygen species are mainly produced just by the mere fact that we breathe. And so the body has, and after their production, they do have functions, they play roles in the immune system, and they also have roles in signal transduction. But the problem is, when they tend to accumulate in the system, they can be deleterious. So it's also been shown or established that individuals that are infected with HIV/AIDS actually have a problem with clearing reactive oxygen species that are produced. So when this clearance, when there's a problem with the clearance, what happens is an individual is said to be oxidatively stressed. So it has been shown that some individuals are unable to clear reactive oxygen species, possibly due to liver toxicity. And in HIV/AIDS patients, some people have suggested that drug-induced liver toxicity could also be a factor, and others have also shown that HIV, the virus itself, with its co-infection, could also cause liver toxicity. Other studies have also shown that individuals that were anemic actually had a problem clearing reactive oxygen species that were produced from respiration and other biological activities. And also, some studies have also suggested glutathione S-transferase polymorphisms. These enzymes are phase 2 drug metabolism enzymes. And what they do basically is to conjugate electrophilic substances with glutathione, thereby enabling their removal from the system. In humans, about 5 classes are known. And it's been shown that of these classes, only the M and the P and T has been associated with individuals inheriting null alleles. And so what happens is when you inherit these alleles, you usually have a loss of enzyme activity. And several studies have shown that individuals that have the null alleles are predisposed to actually, or are at an increased risk of contracting certain cancers, and even acute lymphoid leukemia in children. However, the problem is, in Ghana, there is no data on polymorphisms in glutathione S-transferase. So my work was to basically investigate these polymorphisms among our HIV/AIDS patients, and also assess the activities of these antioxidant enzymes. So the first thing was to assess the effect of the HIV itself, or the drugs that these people are on their hematological profile as well as their liver function. Then secondly, estimate oxidative stress markers in them. And finally, try and investigate these polymorphisms in this enzyme. So after ethical clearance was approved by the IRB board here, I went ahead to recruit my HIV/AIDS patients from the previous unit at Polywood Teaching Hospital. This is just an overview of the method. For the polymorphisms, I use a multiplex PCR assay. And to determine progression of HIV, CD4 count as well as viral load were determined. The liver function, these tests were actually assessed for liver function. And then for the oxidative stress markers, I only worked on these 3 of the markers of oxidative stress. And these demographics here basically show that from here, the BMI and body fat, as well as the visceral fat of these individuals basically suggest that these individuals were not overweight, because it's been found that individuals that are overweight or obese tend to produce a lot of reactive oxygen species, and hence they tend to be oxidatively stressed. So this basically shows me that there wouldn't be any possible confounders from the weight of the individuals that I recruited. I then went on to assess the CD4 counts and viral load, and it was found that individuals that were on treatment actually had significantly higher CD4 counts and lower viral loads when compared with those who were not on treatment. And it also found that individuals who were on treatment were more likely to have their CD4 counts being more than 350 when compared with the ART-naive individuals who were more likely to have their CD4 counts less than 200. So to set the ball rolling, I decided to investigate if this virus or the drugs these people are on would have an effect on their blood or the liver. So what I did was, from the hematological profile, it was found that individuals that were not on the drug were actually anemic. And this is confirmed by the values of the hematocrit as well as the NCD. The high value of the RBC basically shows that these people had iron deficiency anemia. I then went ahead to assess the effect of the drug or HIV on their liver. And from the liver function, what was observed was significantly higher values of ALP, AST, and GGT were observed in the HIV individuals. And this suggests that with those who are on treatment, it can be suggested that it's possible that the drugs could be causing these values to actually be elevated. And also, among those who were ART-naive, what we did was I screened for hepatitis B. I didn't screen for all the other hepatitis virus. So it's possible that they could have a co-infection with other types of hepatitis or any other kind of infection that affects an individual's liver. So that could be a confounder there. But what's the take home from this slide is basically that individuals who were on treatment had significantly elevated liver enzymes, and even those who were not on treatment also had the same thing, suggesting a possible liver toxicity. So from this, does this affect the way they are able to clear? Does this affect their ability to clear reactive oxygen species from the system? Hence, I examined the activities of these enzymes. So for this, individuals who were not on treatment had significantly lower activity of glutathione reductase activity. And even when stratified according to CD4 counts, it was observed that their activity was even low. Individuals with CD4 counts less than 200 were significantly less. And glutathione reductase basically recycles glutathione in the system. And this is the main antioxidant that we have in our system. So also, what I observed was that individuals who were not on treatment still had significantly lower reduced glutathione levels in their system. And that was the same case for those whose CD4 counts were less than 200. Then with the superoxide dismutase, we also found that individuals who were not on treatment still had significantly less. And the same thing was observed with those whose CD4 counts were less than 200. So I then went on to assess the gene polymorphisms in my study population. And this is a representative here of what I observed. So from this, the band size of GSTT is about 480 base pairs. So individuals, for example, the patient whose sample was in lane 23 had the GSTT present, however, the GSTM was absent in this individual. And if you look at lane 32, you can see that this individual basically lacked a functional enzyme in both of these. So the gene was absent here, and the gene for T was absent, and the gene for U was also absent. So from this, for the purpose of this presentation, I collated the data based on their CD4 counts. And the odds ratio basically showed that individuals who had a deletion of both GSTM and GSTT were at a significant risk of actually having their CD4 counts falling below 200. And from this, the p-value actually shows that it was actually significant. So from this, I concluded that HIV/AIDS patients who were not on ACT were anemic from my study population. And also, HIV-associated and drug-induced liver toxicity was also observed in HIV/AIDS patients. Another thing was that increased oxidative stress was observed in the ACT-naive HIV/AIDS patients and those whose CD4 counts fell below 200. And there was also an increased risk of individuals who had both deletions to actually have the CD4 counts falling less than 200. So with this, I'd like to acknowledge WRC for their funding and my supervisors for their immense help, and also to Emmanuel Tego for the idea behind this project, because nothing is known about polymorphisms of this drug metabolizing enzyme among Ghanaians. So this, I'd just like to thank you all for your time and
Thank you very much, Joshua. Any questions for this presentation? There is one at the back, please, Mark, I think.
Thank you very much for a very nice presentation. I'm just wondering, if you're looking at HIV patients, we know that they are prone to other opportunistic infections. Did you look to see which other infections that they had and whether the infections influence the data that you got?
Okay, what we did was initially we had a clinician on site who actually assessed them, and he also took a look at their folders for certain medical conditions that they had. But then from the hepatitis, we were not so satisfied with the response we were getting from them. So we got the kit and then we ran a test of hepatitis B, because that's what's more prevalent among Ghanaians nowadays. So we checked for hepatitis, but then we didn't check for any other hepatitis virus. And it's possible that they could have co-infections. But one thing we made sure was that there was no co-infection in TB amongst our study population because we just wanted to assess only HIV individuals. I'm sure there could be based on, because we're basing this on the honesty that the patients were telling us, and also from what the clinician told us from their medical record. So it's possible that if the patients were not being honest with us.
My name is Aniweya with WAPI. I want to find out from
you showed that there is deletion in some of the enzymes with some of the patients. And will you associate that with the disease or the genetic background of the patient? And how will you relate this deletion as a factor for your condition?
Okay. The thing is, this deletion, the thing is, the deletions are actually inherited. Studies have shown that these individuals here show that the deletions are inherited. So it is possible that an individual acquired this probably through birth, and I don't know whether a person can actually get it from other external factors, because from the search of the literature, all I found was this, that it was actually inherited.
A quickie, yeah?
In the model that you used, right? Your covariates, you didn't really talk about the covariates. You said
You looked at co-infections a little bit, but the question I have is, you only found the significance when the CD4 count was less than 200. Is that true?
Yeah.
So if you run the model, and as a covariate in that model, and your block 2 predictors, for example,
Yeah.
just stratify on CD4 count versus getting rid of a large part of your population,
Yeah.
you'll probably find additional significance because your sample size will increase.
Okay. Yeah.
So you can just dummy code
Okay.
your predictor variables, your covariates.
Yeah.
Thank you, DJ. We will move on. Thank you very much. And we'll move on to the last presentation in this session, which is given by Idrisu Alabira, who will talk to us about the prevalence of human papillomavirus among women attending Ridge Hospital in Accra. So, Alabira.
Thank you. Good afternoon. My name is Alabira Idrisu. I'm here to present on the prevalence of human papillomavirus among women attending Ridge Hospital.
Closer to the mic.
To talk to the microphone. If it's on.
Yeah, the outline will take this from the introduction, problem statements, rationale, objectives, methodology, results, conclusion, and recommendations, and then the references.
I can hear you. It would be good. Yeah.
Cervix is an organ that is found only in women. It forms the neck of the uterus. And cervical cancer is the most common cancer after breast cancer in the world. And the WHO has estimated 529,000 new cases and 275 deaths occur out of 529,000 new cases every year. And over 80% of these cases occur in developing countries. And cervical cancer is a leading cause of gynecological cancers in Ghana. And it forms about 57.8% of our gynecological cases. And it is also the leading cancer in Ghana. It has overtaken the breast cancer. And every year, about 3,000 women are diagnosed with cervical cancer, and 2,000 die out of that. And HPV, or human papillomavirus, has been associated with cervical cancer. And about 13 high-risk HPVs have been established to be involved in cervical cancer. And HPVs have been categorized into two based on their ability to cause cancer. So those that can cause cancer are called the high-risk human papillomavirus, and those that cannot cause are termed the low-risk human papillomavirus. And the infection usually starts with microabrasion, and it actually infects epithelial tissues, and usually it infects the basal cells, and at this level the HPV just maintains its genome in the dividing basal cells. So as the cells begin to proliferate, then they then bring in their ability to multiply, and then when it reaches the middle zone, they use their E7 and then the E6 to amplify their genome, and the packaging then comes in when the cells reach the superficial zone. And it is the E4 that it uses to produce the L1, L2, and the L1, L2 are the capsid proteins before the viruses are packaged for release. And it's been observed that certain risk factors are associated with HPV infection, and they are sociodemographic characteristics like sex, age, marital status, literacy, occupation, religion, and ethnicity, and then gynecological history, parity, pregnancy, and the use of oral contraception, and sexual activities like the age at sexual debut, multiple partners, new partners, and then medical history, the sexually transmitted infections, HIV or immunosuppression, diabetes, alcohol, smoking. The problem is that it's been observed that about 60 to 70% of cervical cancer cases worldwide are caused by HPV type 16 and 18. And in this country, especially at the time that this study was done, we did not really know the particular genotype that were found in the country. And it has also been observed that there's an increased incident rate in Ghana as compared to the sub-region like West Africa, and we need to find out why we have an increase in incidence rates of HPVs in Ghana as compared to West Africa. And cytology or pap test has been used for the screening of HPVs in the country, but it has also been observed that this particular test lacks sensitivity because of inter-observer differences. And then in some facilities, the visual inspection with acetic acid has also been used, and it's been observed that there is higher level of overdiagnosis with the use of this method. The hypothesis is that HPV 6, 11, 16, and 18 are prevalent among women attending family planning unit of Rich Hospital. And then sociodemographic characteristics, sexual, gynecological, and medical histories are independent predictors of HPV infections. The objectives are to determine risk factors that are associated with HPV infections among women attending family planning units of Rich Hospital, and the specific objectives are to determine the prevalence and distribution of specific HPVs like 6, 11, 16, and 18, among the women attending the unit, and then to determine the association between risk factors and the prevalence of HPV. Ethical clearance was sought from Ghana Health Service, and the study location was family planning unit of the Youth Hospital. The study population was women aged between 19 and 16 years who attend the hospital for cervical cancer screening. And 201 women were recruited into the study. Cervical samples were taken from them, and then multiplex PCR was run, and questionnaires were administered to get data on sociodemographic, sexual, gynecological, and medical history. And the HPV was then used as the outcome variable, and the data collected from the questionnaire was used as the independent variables. To address objective number 1, cervical samples were taken and then DNA was extracted from them. Multiplex PCR was done using dual priming oligonucleotide technology from Seagen, and then gel electrophoresis was also run for the detection of the HPV types. And the HPV types were detected comparing the bands of the test to the control bands. Objective 2 was addressed by collecting the questionnaires, coding the data, and then the prevalence of HPV was determined. Logistic regression and chi-square were used to determine the odds ratio. Out of the 201 women, the mean age was 38.4, the standard deviation was 11.8, and the range was between 19 and 16 years. Those who were positive were 32, the mean age was 40.2, the standard deviation was 12.7, and the range was 19 to 60. And then those who were negative were 169, mean age 38, standard deviation 11.6, and then the range was 20 to 60 years. And then the HPV types percentages were also determined. With the HPV 611, it was 2/201, which is about 1%. The HPV 16 was about 2.99%. HPV 18 was 1.99. High risk common. These were HPV genotypes that were determined collectively, other than the HPV 16 and 18, and that was 9.95%. And the total prevalence was 15.92%. With the socio-demographic characteristics, it was observed that prevalence rate was increasing with respect to increase in age, even though it was not significant. And then it was also observed that the prevalence was higher among people who did not attain formal education as compared to those who attained formal education. And then with respect to occupation, it was observed that those who were manual workers had a prevalence rate higher than the rest. And then with sexual history, it was observed that none was significant except multiple partners. Those who had multiple partners had a odd ratio of 2.68 with the p-value of 0.01. And the gynecological history was also not significant. The medical history wasn't also significant. In conclusion,